Okay, welcome to Graphing Quadratics Notes Part 2. Um, we are going to move on to section 8.4 now. So I grouped sections 8.1 to 8.3 together. And now we're going to move on to section 8.4 here. And 8.4 is going to talk about graphing quadratics in vertex form. And so we're actually going to do our examples before we talk about what vertex form is. Okay, and so what we're going to do is we're going to make two tables here, actually. The first one I'm going to graph in purple, and it's going to be for this function. And then the second one that I'm going to graph is going to be this one in blue. Okay, so I'm going to go to my graphing calculator. I hit y equals, all right? And then I'm going to graph just x squared. And you actually did this already on the last one. So if we start at -4, that's 16. -3 goes to 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, and 9. Okay? And so then we go to our graph and we graph this. And we have -3, +9, -2, +4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So this is what you did in the last section. Okay, you just plugged it into the graphing calculator, you found the table, and then you graphed your parabola. Okay? So now we're going to look at this next one. Okay, and if you notice, there's something a bit different about this one. If we plug it into the graphing calculator, we hit the parentheses, and then x minus 2, close your parentheses, and then square it. Okay, and if you go to your graph, just so that we can kind of see the picture here, it looks like the same parabola, just somewhere else on the graph. Okay, so let's go to our table and let's plot the points. I'll start here even though we can't really see it. We'll say -2, 16, -1, 9, 0, 4, 1, 1, 2, 0, 3, 1, 4, 4, and 5, 9. Okay? So let's plot that. We've got -2, 16, which we can't plot, -1, 9, 0, 4, 1, 1, 2, 0, 3, 1, 4, 4, and 5, 9. Okay? And so we draw a parabola as best as we can. Mine's kind of not as great as I would want it to be, but that's okay. Okay. And so we've got two parabolas now. And so one of the main focuses of this section is comparing these two parabolas and what's different about them. And if you notice, okay, we're going to talk about several things that are different about them. But the main difference, the most easy difference to see is that it's just moved over. Okay, so if you look, the vertex moves over 2. And this purple point here at 1, 1 moves over 2 to be that point over there. And if we want to move this point over 2, it would correspond to that point over there. And this point moved over 2. Okay, and so the way that we say this is describe the differences. It's just shifted to the right 2. That's what we say. Okay, you can say moved to the right 2. Shifted is a little bit better. You also need a T on the word right. Okay, it's shifted to the right 2. All right, so let's take a minute here and let's talk about the vertex of both of these things. Okay, so the vertex of the purple parabola is at 0, 0, but the vertex of the blue parabola, the second one there, was at 2, 0. Okay, which should make sense if we've shifted to the right 2. Okay, let's now look at the axis of symmetry. okay? So for the axis of symmetry here, I'm going to do the first one in yellow. So for the purple graph, this is the axis of symmetry, and we've talked about that several times, okay? So that axis of symmetry is at x is equal to 0, all right? And I'm going to do in pink the axis of symmetry for our blue graph. So if we draw that like that, okay, the axis of symmetry there would be x is equal to 2, which would make sense if we've shifted to the right 2. If we shift to the right 2, that means our axis of symmetry shifts to the right 2. Okay? Let's talk about the domain. The domain is actually going to stay the same. So the domain of our purple graph, well, if we were riding a roller coaster, we would never fall off, so that's all real numbers. And the domain for our blue graph is going to be the same, all real numbers. Okay? And let's talk about the range. Okay? For this one, the range of the purple graph is going to be y has to be greater than 0, greater than or equal to 0, excuse me. Okay? And if you notice, the range doesn't change on the blue graph at all either. The y values don't change. If we move right and left, nothing's changing about our y. The only thing that's changing here is our x. Okay? So the range stays the same between the two things. All right? Let's talk about y-intercepts. So for the y-intercepts, the y-intercept of our purple graph was 0, 0. The y-intercept of our blue graph was 0, 4. And that's just because the points, the point that corresponded to the y value of 4 on the purple graph was 2 away from the y-axis. Okay? So that's kind of a nice pattern to notice. For x-intercepts, the x-intercept of the purple graph was 0, 0. But the x-intercept of this blue graph is going to be 2, 0, which would make sense if we've shifted over 2 units. Okay? 2 more things I want to talk about here. We've talked about these in class recently. Is where this graph is increasing and where this graph is decreasing. Okay, so let's start with the purple graph. The purple graph is increasing on its way this way. And remember, we compare increasing intervals to the x value. So we're increasing starting here where x is bigger than 0. All right? And we're decreasing on the other side of that same value. So that means we're decreasing at x is less than 0. Okay? Great. So then here with the blue graph, we're increasing on this side of the vertex. So that means we're increasing when we're bigger than 2. And that means we're decreasing on the other side of 2. So notice because we've shifted to the 2 right, that also means that our increasing and decreasing intervals are also going to shift as well. Okay? So the main point of this is when we add extra values in here, like a -2 there, it's going to move things. It's going to move a lot of things, and it's going to change kind of where we come from. Okay? This, by the way, is what we call a parent function. It's the simplest form of the function. So we call x squared the parent function, and then we do stuff to it. Sometimes we're going to multiply it. Sometimes we're going to subtract something. But this is as simple as it gets. There's no numbers next to that except for an x squared. Okay? Let's look at one that's a little bit more complicated. First of all, I want you to add a negative out in front here. We need to see what happens when we turn negative. Okay? All right, so let's go to y equals. I'm going to graph again the parent function of x squared. And I think by now or soon you should have that memorized, okay? And we're not going to talk about increasing or decreasing or the vertex of this. We're just going to draw it on our graph so that we know where it is, okay? So that's y equals x squared. That's our parent function. That's what we are going to compare it to, okay? Now let's go to y equals and plug this one in. So negative 1/2 times x minus 4 squared plus 1. Okay? And then we're going to go to our table. And we get some gross numbers, but that's okay. Let's start at the point 0, -7. 1, -3.5. 2, -1. 3 is 0.5. 4 is 1. 5 is 0.5. 6 is -1. 7 is -3.5. And just because we can, I'll write down the 8 one as well. 8, -7. Okay? All right, so now we go to our graph. And let's graph these points. 0, -7. Oh, that's right here. 0, -7. 1, -3.5 is right here. 2, -1. 3, +0.5. 4, +1. 5.5. 6, -1. 7, -3.5. And 8, -7. Okay. And so now we connect our dots. Okay. And so now you see several things have happened. Okay. So before we talk about what's happened, let's fill in our box over here. I'm going to draw my axis of symmetry just so I can see it. Okay. Now let's talk about this vertex here. The vertex is now at, it's a maximum, and it's at the point 4, 1. Okay? We've got an axis of symmetry, and that's at x is equal to 4. Okay? The domain is all real numbers, but the range, so things are happening down this way, and things start happening at that y value there of +1. So all of our y values have to be less than or equal, I don't know why I put a positive there, less than or equal to 1. Alrighty? And then the y-intercept is down here, and that is at 0, -7. Okay? And we've also got x-intercepts. Okay? And we don't know what those are. So this is where we have to go in and we have to find them on the graph. Okay, so we go to our graph. It's graphing, and you see that they're decimal points. Okay, so let's walk through this again. To find the x-intercepts, we hit second, trace, and we choose 0. So we hit 0. Okay, and it asks for a left bound. And so if we're riding the roller coaster, it would be before we hit that axis, we click enter. And then it's asking for a right bound. So where are you to the right of your 0? And so we're to the right, thinking about side to side. We're to the right of our 0 there. And then it asks you that dumb question of guess, and you're like, yes, please. And the 0 happens at, we'll say 2.60. Okay? 2.60. And then there's another one. So we repeat the process. We hit second, trace, 0. Okay? And then we go over, and we're going to be to the left of our 0 before we cross this time. And then now we're to the right of our 0. And then we click enter. And this time it's at 5.4, 0. Okay? Those are our zeros. All right, now, lots of things have happened to this parabola. Okay? So what do you notice when you compare the functions and their graphs? Okay, first of all, let's talk about where it moved to. Okay, so let's compare the vertex. You've got a vertex here at 0, 0 and a vertex here at 4, 1. So it moved to the right by 4, and then it moved up 1. We know that at least happened. And if you look at all of the points, we'll talk about here in a second what that means, but we move to the right 4 and up 1. Okay? You also notice two other things. First of all, it's upside down. Okay? So we call that a reflection. So there's a reflection here. Okay? So it's like we've taken it and we've just reflected it. We've turned it upside down. Okay? There's a reflection. But also, if you notice, okay, the vertex here goes from 1 and then it goes over 1 and up 1, over 1 and up 1. But here with the vertex, it goes over 1 and down a half and over 1 and down 1/2. And so what that essentially does is it makes the parabola wider. Okay? And we're going to talk more and more about this in class. This is just kind of an introduction to what we call transformations of parabolas. But just so you just have to be able to eye it and say, okay, well, it moved over and up, it looks like. And it's upside down, so that's a reflection. And then it's also wider, okay? And we're going to talk in class about how the equation fits into this. So now that we've kind of seen this a little bit, let's talk about here now the fact that we have a form of a parabola that looks like this, okay? Standard form looked like y equals ax squared plus bx plus c, okay? That is standard form. So this is called vertex form. And the reason that we call it vertex form is because the equation actually gives us the vertex. So if we look over here, let's go here. Well, no, let's not. Let's go here first, okay? The vertex of this parabola was at 4, 1. And if you go to your equation here, you see the numbers 4 and 1 already in there. The only thing that's a little bit different that we have to be careful with is this minus sign, okay? Because obviously the vertex is at a positive 4 and 1. And so what we say in our original equation is the negative is what stands, okay? The negative is already included in the equation. So we ignore the negative essentially and just look at the h value and the k. Now, we'll talk about in class that if this is positive, that means that you had a negative vertex, okay? Negative x coordinate. So the point h comma k is the vertex, so either the maximum or the minimum of the parabola. And that last thing that I just described might be a little bit fuzzy to you. We're going to have to talk about that in class, but we will do that in class coming this next week. So the main points that I want you to walk away with, first of all, just being comfortable plugging things into the graphing calculator, okay? Being able to identify all of these things from a graph, increasing and decreasing, I know we still might be fuzzy with, okay? And comparing what is happening with graphs. So if I gave you two graphs on a graph, could you tell me what was different about them? Okay, those are the three main points of this. So hopefully that makes a little bit of sense. And we can clarify anything in class next time. Okay, see you later.